How's everybody doing? Today we're going to talk about solving equations with radicals. Oh, what's a radical? It's like a square root or a cube root or something like that. So if we had this, if we had the square root of some number, x, equals 4, how do we get rid of the radical? How do we get rid of this? The radical, again, is that now there's a 2 in here, we just don't write it because we don't have to. We're lazy. Why y'all looking at me when I said lazy? Yeah, okay. So how do we get rid of the radical? You square it. And remember, it's an equation, so whatever you do to one side, you have to do to the other side. So when you square a square root, in other words, when you square the radical just goes away. Because really what this means is the square root of x squared, once you square everything, equals 16. Now, what's the square root of x squared? X. So it's really pretty simple. When you square a square root, what happens? The radical, the square root symbol, goes away. That's all there is to it. It's really very simple. Now, the square root symbol, or the radical, doesn't have to be square root. It could be cube root, fourth root, fifth root, whatever. When you square it, the square root goes away. So what if we have, the radical, when we're talking about order of operation, the radical acts like parentheses. So if we're solving an equation, it's the last thing we're going to do. So if we have this, if we have the square root of 3x plus 4 equals 8. Again, what do we do? How do we get rid of the radical? That's the first thing we want to do, is we square it. And again, whatever you do to one side, you have to do to the other side. So when you square a square root, the radical just goes away. So we have 3x plus 4 equals 64. 8 squared, 64. Now we have a real simple algebra problem. We subtract 4 from each side, and we get 3x equals 60. Divide by 3. Hope y'all can see this down here. X equals 20. To check it, you plug it back in, and like that. Now we're going to plug some of those back in because some of the answers do not work. And those are called extraneous solutions, and we'll talk more about that here in a minute. So what if we have this? What if we have the square root of 5x minus 1 minus 1. Now the minus 1 is outside of the radical, outside of the square root symbol. What did I do? Stupid boy. I'm sorry, not minus 5x minus 1. Man, oh man, plus 3 equals 0. I'm sorry, I'll do better. No, you know I won't. Okay, now the 3 is on the outside of the radical, so we're going to, remember, we do order of operation backwards. First we get rid of addition, subtraction, then multiplication, division, blah, blah, blah. Okay, so we subtract 3 from each side. That's a 3 here. And what do we have left? The square root of 5x minus 1 equals negative 3. Okay, again, how do we now we want to get rid of the radical. How do we do that? Square both sides. Now remember, you have to square the whole number, not just the 3. And when you square a square root, the radical just goes away. So we have 5x minus 1 equals 9. Right? Right. and we add 1 to each side, and we get 5x equals 10, divide by 5. I'm going to move this over here. X equals 2. Now, we have to make sure that this is the correct answer. And how do we do that? We plug it back into the original equation. I'm going to erase this so we can see what in the world we're doing here. We know that x, we calculated that x equals 2. So we plug it back in. We get the square root of 5 times 2 minus 1 plus 3 equals 0. Or does it equal 0? Now we subtract 3 from each side, and we get 10 minus 1, which is the equals, or does it equal, negative 3. Now 10 minus 1, of course, is 9. Does that equal negative 3? What's the square root of 9? 3. Three does not equal negative 3. Or what we could have done is, rather than doing this, we could have done this. The square root of 5x minus 1 plus 3, does that equal 0? Now we could have done this. 5 times 2 minus 1 plus 3, does that equal 0? 5 times 2 is 10. 10 minus 1 is 9. So the square root of 9 plus 3, does that equal 0? 3 plus 3 is 6. Of course, does that equal 0? 6 does not equal 0. So this is called an extraneous solution. A-N-E-O-U-S. Extraneous solution. O-L-U-T-I-O-N. You're going to see more and more of this. Thankfully, not a whole hell of heck of a lot. But extraneous solution means that it's not, even though our algebra was correct here, it's not a good solution. Okay, so that's all we have for this lesson. And next time we're going to talk about complex numbers.